Hello, welcome to Ask an Expert at the European Environment Agency. Today is the World Soil Day, and of course, we are going to talk about soil. It's something that is so precious to all of us, and it is also one of the foundations of life on Earth. My name is Gülçin Karadeniz, and I work at the European Environment Agency's communications team, and I have two colleagues joining me today, Rainer Baritz and Manuel Meyer. And this is a live chat, and of course, if you have any questions, and we hope that you do, Rainer and Manuel are here to answer them. Anything about soils, what we do on soils, and what kind of information we can share with you. So maybe we start with some simple questions, but don't forget, just insert your questions in the comment section. Rainer, you're one of our soil experts, maybe the soil expert in the house. Why should we care about soil?
That is a good question, and it's discussed quite intensively at the moment. Many of you know that the European Commission has launched a policy proposal for soil protection. So why is that? Why is it necessary? And we have increasingly scientific evidence also that soils are degraded massively in the world, but also in Europe in particular.
What do we mean by soil degradation? Can you just give some examples?
Soil degradation is the soil have a capacity to function, and they help us to grow our food. They provide nutrients for plants. They enable water storage so that during at least some dry season, soils can still provide water for plants to grow. So basically our food depends on it, and not only our food. Soils are hosting about a quarter of the world's biodiversity, which is just its soil. So this functioning of soil is then
it's important for us, right?
Well, that is degradation. Soils cannot function properly.
Yeah. You mentioned some of the policies, but we'll come to that. Why are Europe's soils degrading, if I can say? What are the issues that we face when it comes to soils?
Well, soil interact with many partners. The main partner is the human being managing the soils. So we disrupt soil, we plant in soil, we prepare the soils. Climate has also an impact on soils. There's an interaction between soils and climate. And these are the processes that act on the soil and make it important.
Mm-hmm, mm-hmm. I think one of the things that the soils, while we interact with it, as you say, is soil sealing, right? Manuel, what is soil sealing? You work on Copernicus land monitoring, and you work with soil sealing, right?
Indeed. Well, soil sealing is basically when we cover the soil with an impermeable layer.
Which is?
Mostly these days it's concrete and asphalt, and this cover of the top surface of the earth, we can monitor this with satellite data, earth observation as it is called, and nowadays we have tremendous capacities thanks to Copernicus to monitor the earth in a repeated and also regular manner, and we have dedicated products that measure soil sealing in a way. So we measure.
So the cities are growing, we are building more roads, we are building more buildings and more, pavements and everything. And that you can monitor from Earth observation tools like satellites and things.
Indeed, yeah. We can measure at least the cover of sealing. We cannot always say, okay, this sealing is, for example, this and that use of land in a way, but we can say it is land cover that has changed, that has been converted to some kind of sealed surface in a way. Mm.
Yeah, we'll talk about what happens when the soil is sealed. But you were talking about other kind of, is pollution a factor, for example, when we talk about soils?
Pollution is one of the big soil threats that we are dealing with, of course, very intensively in urban areas, and to a large degree also in agricultural areas where chemical substances are applied to the soil, sometimes to help plants grow, but sometimes it can be also in the vicinity of mining. or other what we call contaminated sites. So soil is quite exposed to the input of contaminants that then also affect other soil functions, like life in the soil.
Yeah, of course, because soil is quite rich in terms of life.
Yes, as I just mentioned, the biodiversity is huge that we find in the soil, and it's a bioreactor actually, where many processes that are, for example, related to nutrient availability are mediated by microorganisms. And it's quite an endeavor now also to use modern biochemical methods to find out, to detect the species that we have in the soil. More than 90% of the bacteria and fungi living in the soil are not really determined yet. No? So it's a hugely complex engine that operates and provides what we need for the plants to grow in the soil.
And I can imagine that, you know, soil in one area and the biodiversity it contains is quite different than, let's say, you know, where you live and where you live, right?
Yeah, that's a bit of a challenge when you then make also a soil protection policy proposal, because the conditions are so different. In Central or Northern Europe, for example, we have most of the peatlands that are under agricultural use, and they impact our greenhouse balance. So this is more Central Northern Europe. In Southern Europe, we have a great deal of permanent crops that contribute to a large proportion to erosion problems. So what we have in Europe is quite a complex gradient of different soil, land, and then also management conditions.
Mm-hmm. Mm-hmm. You mentioned some products from, you know, the Copernicus Land Monitoring Service. Is there any insights that we can get from these products as to the diversity of these soils?
Well, we can, with some of our products, of course, monitor and observe how land is really used. We can, not purely based on Earth observation, but also with the need of, with ancillary data and also image interpretation. We have certain flagship products, such as Corinne Land Cover, where we can also get a very good overview over Europe, how land is used, how this land use changes also, and partly we can then indirectly measure what the implications for soil are. But this is not our job, of course. We are producing the data. Experts like Rainer and others can then get to some conclusions on.
But I can imagine that local authorities that have to do something about that can also get that kind of insight for their decisions as well, based on the Copernicus data.
Absolutely. Copernicus is about, as you would call it, evidence-based decision support. Definitely. It's a unique source of information that is freely accessible and is open to everyone. So not only national authorities or regional authorities can use it, everyone can use it, from scientists.
And it's free of charge.
Definitely, you can do whatever you like with it.
Yeah. Just as a reminder, if you have questions for Rainer and Manuel, you can insert them in the comment section and we will ask them on your behalf, and you'll get to hear what kind of information they can share with you. You talked a little bit about, we talked a little bit about soil sealing, but is there anything that you would like to tell us more? More and more of Europe is being sealed. Can we see trends? What are the main issues? What can the data tell us?
Well, we produce the data, as I said. It's our EEA colleagues that actually then interpret the data and then also derive information from it. But of course, I think it's not a secret that cities are still growing in Europe, and not only in Europe, and that when cities grow, they usually incorporate the surrounding areas. And these are mostly natural or semi-natural areas.
What do we mean by semi-natural areas?
Well, land that contain or that is managed in a way, but still is contains, for example, vegetation. This is, for example, a pasture or something. So most of the areas that cities, when they grow, incorporate are they're spreading, and they incorporate their surroundings, and mainly soil sealing is at the cost of agricultural areas and also pastures.
Mm-hmm. Mm-hmm.
But if I can add, this is really important for the soil protection perspective, no? Because we know that from sealing, we lose soil functions forever. So the soil is
So it
really
can never
lost.
recover. So imagine that you remove the asphalt from an area, or the concrete.
Yeah, you
So
remove
what?
the asphalt, then you have no real growing media left because it has been damaged or even displaced from the construction processes. So in a normal urban development process, you import soil from a functioning soil from another site that you then put back on so this is kind of a remediation process in a certain way in order to get a productive soil back.
So what happens with the unproductive soil that you remove?
That is either used for another construction process. This is possible. We are living in a time of circular economy, so you want to reuse what you are extracting or replacing, but very often it's either legally or illegally dumped. And very often these soils are also contaminated because where this happens, some contamination goes along with the process. And this is in fact an element why the proposed legislation that we are discussing now in the European Union contains the element of excavated soils.
Mm-hmm.
And on the other hand, with regard to restoration and remediation, the integration of soils into use in the future, also an element of decontamination and remediation.
Yeah, because it's a finite resource, right? I mean, when you look at the bigger picture, when we talk about productive soils
definitely.
and things, and in some bits, it's like
it takes 500 years, so 2.5 centimeters of soil grow.
Yeah.
So you can imagine that it takes forever until a soil naturally finds its way back into a full capacity of functioning.
Mm-hmm. Mm-hmm. Well, the today's World Soil Day focuses on soil and water.
Yeah.
And sealing has a component to it. What can we say about that? I don't know. You want to start?
Well, soil degradation is a global process. In many ways, food security is the first thing that comes into mind, climate change another, but also the soil resource. Because any drop of rain that comes back to the ground and replenishes our groundwater resources percolates through the soil. And the soil has various buffer and filtering capacities, so we have also pollutants coming in or chemicals applied to the soil for plant protection, for example. That is also in the soil for which we have evidence. So the percolating water through the soil is endangered, and thus also our groundwater resources, our drinking water resources. And globally, this is as big of an issue as in Europe. The latest estimates predict that 40% of soils of land is currently degraded in the world. And the last outlook projects is quite dark. By 2050, if we continue land intensive use as right now, then an area of the size of South America would be added to the degraded part of land. I mean, one must really imagine the speed and intensity of land and soil degradation in the world. Where we have 40% in the world, in Europe, our estimates at the moment are 60 to 70% soil degradation. So more than a reason for us to start a protection initiative that asks the policymakers, the legislative, to come into play.
Mm-hmm. Just to clarify, are degraded soils still productive in somehow, or does it have any impacts on what they can produce? Can we say, do we know, or?
Yeah, that is a very tough question. It sounds simple, but it's very tough, because going along with the policy idea is what actually means a healthy soil. Because even if some functions are reduced, soils still perform. That's why we can manage soils, and they are actually degraded under our eyes. We can grow some crops in subsoils while the topsoils are completely eroded, while we add enough nutrients for the soils to grow, and we artificially also add water. So we can artificialize this kind of land use while the soil is actually heavily degraded. And this is the difficult element that challenges us also in awareness raising for where soil degradation really comes into play, while it is not always very visible. But we can measure it, and we can measure it to the extent that we can say that we have at the moment a projected loss of more than €1 billion of euros to land, to productivity losses due to erosion. No? But you cannot see it when you stand in the field because something grows there. No? So it's a tricky thing to define what health really means.
I can imagine. But at least soil sealing and the fact that water cannot percolate in, I can imagine the kind of negative impacts it can have, and trying to grow something there afterwards is another challenge. Well, we got a question from our audience, so if you do have questions, please post them now. We still have some minutes with our guests. The question is from a shareholder. How can I make sure that the soil in my garden is healthy and not contaminated or polluted? So I guess, instead of actually maybe stealing, how can somebody keep, their little plot of land safe from degradation?
The best, that's also what I do, is organic matter management.
Which is?
Organic matter is this black material which is coming from organic residues from plants, plant material that slowly decomposes with the help of many, many organisms, millions of organisms in one little handful of soil, and transform the material into a very reactive surface that also contains nutrients. That's organic matter. And especially in kitchen gardens, organic matter management, composting, that's actually the key word, is the issue. And in parallel, to keep it pollutant free, is to make sure that we, just because there is some necrosis or chlorosis, these are the scientific terms, so when you see plants turning colors because of some infect, not just to blindly use some kind of chemicals to treat that plant or that crop that you have in your garden, to find out with which organic or also ecological materials which are ecologically safe, you can protect the plants if we have an infectious disease in your garden. So don't blindly apply the hard stuff. Find out whether there are alternatives, and there are often quite many alternatives.
Where can they find? Because I do have a little balcony, and I like to take care of some plants and things. Is it in gardening communities or because you don't necessarily, you look at the price, you look at the 2-3 options available, and you just go for one of them. So where can we find these alternatives,
Well, when you go into a garden center, you ask, my plant looks like this, what can I do? You get something from the shelf. No? So here you go, you're in kind of in the deadlock. No? But within gardener communities, you find a lot of advice.
Yeah.
This is really amazing. Many people have their self-made solutions, have experience under which soil a certain crop is very sensitive, and can give you advice. There's some really historically grown experience with local growers. That is quite common.
I can imagine. Okay, thanks for the question. Let's go back to the bigger meta picture. And I'm still fascinated by the fact that there's a lot of information that we can get about land cover, and also part of it on soils from Earth observation. How does that work?
Well, basically, for example, with Copernicus, which is the European Union's Earth observation program, you have different components. So you have some space component that is a fleet of satellites. You have an in situ component or ground measurements that are basically contributing any kind of observation systems that are on land, on water, in the atmosphere, etc. And then there is a service component which actually uses both of the data from the in situ and the space component to produce value-added products. And we use a bunch of imageries. You can really say it's big data. I mean, Copernicus produces over 16 terabyte data, raw data per day. And these data are integrated using different algorithms and models to get to a thematic product in a way that is very much tailored to the intended use, actually.
What is the granularity of this kind of data?
Well, it depends on the sensor that we use, but with the common Copernicus sensors, we have a resolution of about 10 meters. But also with Copernicus, there is a bunch of contributing missions, which are national and commercial missions, and they go into the range of a couple of meters. And some of our products that are dedicated to certain specific areas, for example, land use in urban areas or in natural protected areas, they use this kind of data, and they can deliver very high differentiation or thematic quality with different fine, nuanced land use classes and land cover classes.
Yeah. And how often do we get these updated data sets?
Well, we have nowadays near real-time products that are published within a couple of hours after we actually acquire the image in space. And of course, we have products that are more complex and they need some time to be produced, or they aggregate a certain time period. So we have annual products, 3 years updates, and with Corinne Land Cover is 6 years updates. But yeah, remote sensing is very much about really getting repeated measurements, having a time series in order to really monitor and measure how land and also other compartments of the Earth change, and the dynamics that are involved in that. Yeah.
Mm-hmm.
So that's the uniqueness of this technology, I would say.
Yeah. One of the products is on the Copernicus Land Monitoring Service is Urban Atlas. What can people find out about their cities through this product?
Well, with Urban Atlas, they get a very detailed view of how land is used. So the focus of Urban Atlas is urban areas, of course. So we take cities with more than 50,000 inhabitants across Europe.
In Europe, right?
Yeah. In Europe, right. Yeah. And we used to monitor urban areas with this every 6 years, but we're now moving to an increased update cycle of 3 years. So there will be 2021 and 2024 produced. And it also includes so-called building block heights, where we can also get the height of buildings. And also together with soil sealing, this can be a very important information about urban climate.
Mm-hmm. For adaptation, for example, because many cities face flooding because of climate change, excessive rain and stuff like that, and if they have too much sealed, so they should kind of,
Indeed. It's not so much a soil topic, I would say, primarily, but soil, of course, contributes. I mean, you need these open areas in cities as well, I guess. To have an area that is actually nice to live in.
And green spaces and so on and so forth. Well, we have a few minutes left. Let me just check if there are questions. If you do, you can always write them for the next few minutes. But what is, of course, you're working on soil, you're working on Copernicus data. What is next for you? What are you going to work on next?
In EEA, we are looking quite intensively at synergies between different policies and different areas of environmental protection. So there are initiatives under the European Green Deal that look into zero pollution, that look into the chemical sustainability strategy, nature protection. We have also climate change related, climate mitigation related reporting underway, and everywhere soil. So this notion of a new soil protection policy challenges us to embed soil in these different areas of environmental protection, to have the scientific knowledge, how soils are doing in the context of these different areas, and how we can improve it. So this developing the synergies, that is one aspect, but then also we develop an evidence base. What really is health? Where are critical limits where we can convincingly say for land practitioners, for example, that a soil is degraded or not? So we are working on that also quite intensively. And then there's a lot of interaction with member states at the moment to
it's
discuss
a very local issue
the challenge.
as well, I guess. Exciting and difficult, I can say.
And with the Copernicus team, there's a very close cooperation. The team has developed a very interesting portfolio that covers all kinds of land cover that are relevant to understand what's happening with the soil. And so from a user side and the producer side next to me, we have quite an intensive exchange that is increasingly becoming extensive because land take is an issue in the European Union. And with Copernicus, we're really covering it's the primary data source to understand the extent of land take. It's a key number one soil threat. So the interest in having this information in higher resolution even and more frequently in the future is huge. So Manuel and I work quite closely on this at the moment. So this is another field of work that is happening at the moment in EEA.
What about your side, besides what Rainer was mentioning? What's on your desk?
Well, we are an operative service, so for us it's also important to have continuity of our products. I mean, that is a key asset of this whole service. But of course there's, more a trend to increasingly interact with users, to also assess the usability of our products, and then also to have some evolution of the service where we more and more also trying really to get in touch with users and incorporate their requirements from the very beginning, upcoming topics such as soil. So I guess we will be collaborating in the future.
Just a clarification, when you mean users, could it be my brother, could it be my mother who use this kind of data? You talked about the size of the data, but you're looking at like different researchers, authorities. What kind of users would you expect to use this data?
Of course, we know from our users that many of our products are, of course, there to support policies. But of course also scientists are using our data quite frequently, and we also know of some companies that actually build their downstream products upon our products.
And imagine the products go down to 10 meters. I was in a conference this morning, World Soil Conference in Ukraine. They use regional satellite information of 0.5 meter resolution. So users, stakeholders go across the whole society, and EEA has a very nice portal where this information can be retrieved by anybody who is accessible through internet, and you can zoom in and you use a topography to find your town, and then you can get an idea of what is really then in your neighborhood.
Very good. We'll share all these links in the comment section below. Well, I would like to thank you for your contributions and your comments, and I'd like to thank our viewers as well for following us. And if you have any questions, you can always drop them in the comment section, and we can reply to them by writing. So thank you, Rainer. Thank you, Manuel. And happy World Soil Day.
Happy World Soil Day.
Happy World Soil Day.